Welcome to Fun with Functions with me, Matt Yee. I'm going to teach you about the advanced functions and how to solve a particular question in the Nelson Advanced Functions Grade 12 Math textbook, page 227, number 11 from Chapter 4, Polynomial Equations and Inequalities. Now follow along as I teach you how to answer this question. The question is the viscosity V of oil used in cars is related to its temperature T by the formula V equals negative T cubed minus 6T squared plus 12T plus 50, where each unit of T is equivalent to 50 degrees Celsius. This is a three-parted question and is based off mainly the use of an application called Desmos, which is a graphing calculator. The first part is graph the function using a graphing calculator. The second part of this question is determine the temperature range for which V is greater than 0 to 2 decimal places using the graphing calculator. The third part of the question asks you to determine the temperature ranges for which V is in between 15 and 20 to 2 decimal places using the graphing calculator. The first question that will help guide us in answering this question is, what is Desmos? Desmos is an app on the phone or a website online where it gives you the exact graph of any function. This allows us to accurately see the graph of the complicated function in this question. Let's start with answering the first part of the question. Graph this function using a graphing calculator. Remember that the equation is V equals negative T cubed minus 6T squared plus 12T plus 50. This graph shows the full function over an unrestricted domain. Although, in relation to the question, we only need it where T is greater than 0 because the oil temperature in the car will not reach below 0. Therefore, we will only look on the right side of the vertical axis. So this is what the graph of the function is in relation to the context of our question. Let's move on to the second part of this question. This part asks us to use the graph and determine the temperature ranges for which V is greater than 0 to 2 decimal places. The first thing that we need to know to answer this question is how to read a graph of a function. Let's first look at what the x-axis and the y-axis is in general in relation to this question. The x-axis is a horizontal scale on the graph that runs horizontally. The y-axis on the graph is a vertical scale on the graph that runs vertically. In relation to this question, it is key to remember that the y-axis scale enters negative values once it passes the x-axis. We can also say that in relation to this question, that the values along the y-axis represent the viscosity and the values along the x-axis represent the temperature. To give you a visual image, you can see the dotted boxes outlining where the x-axis is on our graph. And the dotted box on this graph outlines where the y-axis is on our graph. The second thing that we need to understand is the symbol in the question that tells us what we are trying to find. The symbol in the question resembles when viscosity is greater than 0, which means when the function of the graph, or the line of the function, is above the x-axis, as I explained before. There's also a symbol that represents greater than or equal to, but in this case, the symbol in our question is asking for when viscosity is greater than but not equal to 0. What is key for solving this question is to look at the graph and find the point where the line passes through the x-axis. This is called an x-intercept. Looking at our graph, we can see that it passes through the x-axis at an x value of 3.095. When looking at our graph, the line is above the x-axis or the viscosity value of 0 until that x-intercept. This means that the range will be from 0 degrees Celsius to our x-intercept calculated temperature. If we look back at the original question, it tells us that every unit of T on the graph is equal to 50 degrees Celsius. So as you can see, that you need to multiply the x value of the x-intercept coordinate by 50 to get the accurate temperature. Again, when answering this question, we have to understand that it is asking when it is greater than but not equal to 0. This means we have to use a round bracket on the right side of the interval. What the interval in the answer means is the range is to 0 to everything but 154.75 degrees. We will now move on to the third part of the question. This part of the question asks us to determine the temperature ranges for which the viscosity is in between 15 and 20 to 2 decimal places using the graph. Another way of asking this in relation to the graph is at what x value is for the y value of 15 and 20. We can see in our graph that the x value for the y value of 15 is 2.791, which means the t value is 2.791 for the v value of 15. Now for our y value, or v value of 20, our x value is 2.6756, which again represents our t value. As you can see here, there are two coordinates that we have gotten from our graph for the viscosity of 20 and 15. Remembering that our y value is equal to the viscosity and the x value is equal to the. As we did for the last question, we need to remember that each value of T is equal to 50 degrees Celsius. This means that you need to multiply each x or T value by 50 in order to get the accurate real temperature. Looking at the product that we've gotten for our temperature ranges, we must use round brackets in our interval to represent that it can be anything but the values of 134 degrees Celsius and 139.5 degrees Celsius. This type of solving could also be used in real-life application. Although you don't think so, there are a lot of jobs out there that use graphs in order to calculate their success or future success. For example, a CFO or a Chief Financial Officer will use a formula for profit in order to find when they will begin to make profit. And this is just like how we in this question used a formula in order to create a graph and read it. I, Matt Yee, would like to thank you for joining me on this journey through Fun with Functions. It has been such an honor in order to teach you this question, and such an honor in order to expand your knowledge in the area of math. I hope you can join me again on my future marks through advanced functions, and I hope that you continue to learn.